Yes, ma'am, you're audible.
Yeah, thank you. Thank you so much. Shriman Kumar, sir.
Yes, ma'am. Yeah.
Yeah, okay. Yes. Uh, a very warm welcome to all of you. Hello, sir. Good morning.
Good morning. Yes.
I'll just introduce, sir. So a very warm welcome to all of you here, and welcome to our 1 week IEEE sponsored capacity building program on Labview programming and hardware interface. It is my great pleasure to have each and every one of you here today as we embark on this exciting journey. So before we dive into the depths of Labview programming and hardware, let me take a very small moment to introduce our distinguished guest, Mr. Shriman Kumar Narsingham. He is a highly accomplished scientific officer at the Nano Optics and Mesoscopic Optics Laboratory of the esteemed TIFR Tata Institute of Fundamental Research in Mumbai. With his extensive expertise in electronics, optics, and optoelectronics, Mr. Shriman Kumar has developed and implemented numerous innovative systems for optical experiments. In his current role at TIFR, Mr. Shriman Kumar has developed and implemented several systems for optical experiments, including satellite, auto tracking, for a quantum communication project, gyro sensor based auto directing systems, autofocus systems using piezo diodes, and radio communication setups, confocal microscopy systems, and modulation system for setups for camera mechanical shutters. In recognition of his work, Mr. Shriman Kumar received the second best poster award at ISPP 2019 organized by Central University of Rajasthan. We are incredibly fortunate to have Mr. Shriman Kumar on as our research person today for this program, and I'm confident that his insights and guidance will enrich our understanding and skills in LabVIEW programming. Once again, I extend a warm welcome to each one of you. Let us make the most of this opportunity to learn, collaborate, grow together over this week. I wish you a very fruitful and rewarding experience in this program. Over to you, sir.
Yes. Thank you. Thank you for your introduction. And just a second, I'm setting up my mouse. Yeah. So good morning, everyone. I'm currently working as a scientific officer in nano optics and mesoscopic optics laboratory in Tata Institute of Fundamental Research, Mumbai. And today, I hope you are gone through several sections of LabVIEW till last day, and I'll introduce the how can we interface and hardware with the LabVIEW for to build automation systems or to build whatever according to your requirements. Even you can implement some serial communication based circuits, and you can make a program for that, and also you can interface that with the LabVIEW. Today, in the same way, we know that there are several Arduino-based microcontroller development boards are available in the market, and I'll show you a few projects on how can we interface an Arduino board, and how can we make some automation-based systems. I'll show one project, and also after that, I'll show you the basic how easy is the LabVIEW for interfacing of hardware, where the conventional mode is the looks like some tougher, where we have to make a lot of syntax based code. And I'll show you first the how an Arduino board is work with their own platform, and later on I'll show you how can we make the programs in the LabVIEW as well. So for that, let me share my screen. So you all know that um, uh, Arduino has their own development platform that is called Arduino IDE usually, where we can, this is the Arduino IDE interface usually, and here when you go to new folder, it can create a new, it can give a new file, and where you can write your own code for to make the Arduino board microcontroller. So anyway, so what is the Arduino board usually? So I'll show you the few. I hope you all gone through the Arduino boards and etc. So today there are in the market there are several Arduino based development boards. So these are basically development boards which can be um, for our various applications, we can choose the particular Arduino boards. So today I'm going to explain a very basic experiment so that I took a 16-bit 80 mega 328 based Arduino board, which is called usually Arduino Uno board. So this is the one. So, and other than this, there are several Arduino boards. Arduino Duo is there, Arduino Mega board is there, and Uno board is there, and Nano boards. So based on our requirement and a project, we can choose the Arduino boards. And currently, this board I'm using, which is a 80 mega 328 based processor, which is a 16-bit sorry microcontroller. And here you can see there are in this board there are like 6 analog input channels, and there are 0 to 13 digital pins, output, inputs and outputs. These are kind of GPIOs. We can configure where if we want to use it as a input or output, and also we can use some of these pins for PWM applications as well. And uh, these are the for power interfacing, power related interfaces. Right now I have the similar board with me, which is you can see here. Let me change my camera. You can see I have one Arduino board here. Sorry, this is a Uno board. Here what I am doing is second. Here I have connected three LEDs to the digital pin of 12, which is in so I have connected a three LEDs here. One is connected to the digital pin of 8, and another is digital pin of 10, and the third one is connected to the 13th digital pin. So these three pins I have connected a red LED and green LED and blue LED to these pins. And using these, I'll show you how can we make a conventional Arduino code, which is a raw code basically, which is in C language. And for that, I have already developed a code that you can go through this. So here I'm defining pins, and after that we have to define what should be those pins, the pin modes, and also whether it should be low or high. We can define here in the setup function. And later on that we can go for loop, wide loop mode. In the loop, we'll define we define the functions of the exact functions, and how do you want to use those pins. Here we'll define those conditions. So for that, here I have connected my red LED to the 8th pin of the Arduino digital pin, and the green is connected to the 10, and blue is connected to the 12. And later on I have built this code, and that just again I'll show you the example. First of all, I'm uploading this code directly to my Arduino board. is getting uploaded. You can see that the LEDs are glowing with the continuous in a sequence, right? So they are glowing with the sequence that I am applying particular delays between on and off a particular LED, and also and also after all these three LEDs are done with their function, defined function, then it will there is a delay of 1 second. So you can see those functions are executing exactly. Um, I'll show you how can we write this code in the Arduino board. First of all, define now the program has been dumped to the microcontrollers. That's why once you are dumped, it will be in a loop and it continuously generate that till you reset this button. And once it reset, again it will go into that loop. Um, First of all, I'll show you how can we make this code. For that, we have to define the pins with the variable names. So you can you can give any variable name for your easy of understanding in the later part of the code. So here I'm giving red LED. Red is connected to the eighth pin, and define blue. Sorry, we can give green. Define blue, which is connected to the 12th pin. So I told the Arduino board that sorry, the IDE that these are the pins I have connected with the particular variable, well, particular LEDs. Then it is a void setup, and you can make a pin mode. So you are mentioning as these are the GPIO pins, and you have to mention that what should be that particular pin you are going to use. So whether it should be input or output, that we can define here. So already I given my digital pin with the variable name of red, right, for the red LED. So I'm making it as an output. And again blue. Okay. Pin mode green. So I told the ID that these pins should be the output purpose only, not the input. So usually by default they are like in the state of output mode only. If we want, sometimes we may need to give the inputs as well for the digital pin. So in such case, these three steps are very crucial. We have to mention. And for my initial state, I'm defining that it should be low, and uh, green should be low. Digital, right? Blue also should be low. Yes. We can give, if you want we can apply some delays as well here, like applying 1 second delay. Then now here we have to give conditions. So how that particular pin should be work. So my pin, which is a red LED with red pin, so that should be glow for some 1 second. I want. I'll give digital right red. I means it's on, and I'll apply. It should stay on for 1 second, and then off digital right, and yes, I'll show one only right now. Digital right, red low. Okay. And there should be delay off. again. So right now I'm applying only red LED. So you can see the change. I'm uploading this code. Yeah, before that I have to save this code. Now you can able to see in the camera that yeah, LEDs are stopped, and you can see only red LED is glowing for 1 second and off for 1 second. So here, by the way, here the delay means it is in milliseconds. So that's why I'm applying 1000 milliseconds. So which means 1 second. So I'm switching on the LED for 1 second and off for the 1 second. And also suppose if I want to add, so up to this code, up to this code, it was already uploaded onto the microcontrollers. That's why it is in a continuous flow. So now I'm editing this code, digital, right? I'm adding another LED. Like suppose I'll add blue, will go in sequence, and I'll physical, right, green low, elements 1000. So again I'm uploading this code. It's in green. I'm uploading the updated code, which then now it should be only red and green are glowing, right? So here this is how we are applying the delays. And this in this way, the basic Arduino programming works, which are like object um, oops kind of C++, and we can define any function here, and we can make the board to understand those things. And in such a way, we have to use this. We have to make such syntax. But here in LabView, I hope you are already introduced to the LabView in a good way. So here, this is a Labview code I already developed. So here there are three LED lights. These are but kind of buttons. My code works like this. So suppose I am uploading this code. Yeah. This second. So for interfacing the Arduino board with the LabVIEW, I'm using a library called links package. So this package I'm using, and they have predefined library files. Now I dump those library files onto my microcontroller board. Now it can understand what is my code is in LabVIEW. So you can see in the camera now, if there is no LED is glowing on right now. And suppose if I turn on the red LED here in the lab view, you can see the red is glowing, right? And if I switch off, it can be switched off. And next is green, and green is on and it can be off, and blue is going off. So we can turn on all these things, and we can turn off all these things. So this much simple it is in the lab view, but I'll explain how exactly we can build this code in the lab view. So for that, you can see my code, the already mentioned code. This is already I developed a small code to demonstrate you the very simple code for interfacing of Arduino. And here you can see I'm using a links packages, links VIs to make my code. And here I'm defining my connection. So which port is connected, which port of the which serial port is connected with the Arduino board. So with, in my code, it is a COM4. You can get this COM4 name from here in from the device manager. For the Windows 11, when you right click on the Windows button, you can get the device manager option here. And once, yeah, here you can see in the under port section, you can see which port was connected with my Arduino board. Here my Arduino Uno board is connected with the COM port. So the same COM port interfacing I'm using here. And after that, this is a for opening the serial connection with the Labview, and this port is useful. And again, there is an output called device name. So here you can see that when the successful interfacing is established between Labview and Arduino, then this name will be appear on this here. That I'll show you later once it is done. And based on this, we can understand that the successful interfacing was established. And then after that, it will be go into this particular while loop. This is a while loop, and in this while loop, I'm defining three digital write channels, as the digital pin should are outputs. We have to turn on the external LEDs, right? So that's why we are writing to these ports. So now I define the pin number 8 and 10 and 12. So these are the connected with the particular pins, and here is the function. So whether has digital pin can accept only zeros and ones, right? So that's why it is a Boolean input, which is a on-off condition. So when you press, it means you are applying 1 to the pin. When you are switching off, this means then it is a 0 to the pin. So you are applying, you are going to 0 now, and you are applying 1 to the particular digital pin. So yeah, and that's why no, just I made these three VAs and three parallel connections, and this particular each particular digital write was defined with the particular input outputs, which is to turn on particular LEDs. So for my easy understanding, I give the input name with the red and green and blue here. And after that, I am closing the terminating the serial interface. So this is the simple code. If you want, we can build along with it. Show how can we build this. So first of all, for interfacing an Arduino board, you can it's like Arduino board is a microcontroller based development board, right? So and that particular the microcontroller will have particular function names that we have to define. We have to call those functions. All those are we have to make a proper communication, right? Even with the Arduino IDE also, there in IDE they have already built library functions which can be easily understandable to this microcontroller. So in the same way, for the Labview as well, to make the interface with the Labview as well, we have to make our code to understand our code to the microcontroller for the conversions, etc. So we have to use a particular package packages. There are several packages available. I will show you VI package manager. Yeah, VI package manager. Yeah, once you download and once you install Labview in your computer, there in the installation page, you can see that there are options for the package manager as well. So you have to install the package manager for the hardware interfacing. So through this package manager, we can install any pre-built library files or packages for our requirement for easy building of our applications in the lab. So this it will take a little time, the VA package manager. So through this only we can I have installed the links package for my to develop the particular code for my Arduino code. And till then I can show you this that okay. As I already have the links package here. Yeah, in the I have installed this package already. So I got this Maker Hub links package in this menu, my toolbox menu, and I'm going to the Maker Hub, and in this menu I'm using links packages, right? So for our application, first of all, we have to make the open, which will be make the establish the serial interface between the Labview and Arduino board. And then you can use, yeah, for these like first of all we have to define the port name here. So, yeah, the serial port name. So it has you can see the here there is a question mark. Here you can see the description of the each pins and of the particular tool in the pellet box. So here this pin has three inputs and three outputs. One of them is a serial port. So we have to make a control, either control or constant. If it is a constant, then it particular will be defined. The predefined port name will be called. Instead of that, we can replace it with a change to control. Yeah, if we are using a control, then whenever you before running the code or while running the code, if you have a particular interface, multiple devices, you can change the serial ports here. Otherwise, as we have only one, we can define here. So as we have only one, we can define it as a constant as well. Change to constant. Yeah, and after that, I told you that once the serial communication established between the Arduino board and this Labview, then you will get an indicator that the particular board name will be displayed here once the connection was established. As you have seen in the device manager, the communication between the my PC and the Labview was successfully established through COM4. That's why I am able to see the Arduino Uno board here name. And in the same way, it will show you the once the connection established with the Labview as well, it will show you the device name here. So this is kind of a indicator for us that a connection was successfully established. So in most of the cases, if the baud rates are different and the baud rates are, if the baud rates are not matching, then you may get errors in most of the cases. If there is any connection error between, issues in the USB connection or your RS-232 connection, then you may face the errors. In such cases, it doesn't show the device name, and also it will show you the error output here. Yeah. Next is the peripherals, and we are using only a digital, right? So, and also it's not a digital read, it's not input, it's output, right? So we have to write we have to use the right. And this is for R, red LED, and this can be for green LED and sorry, green and blue. Yes, and next one is the links. So we have to connect this as the once the connection was established, then the same channel we can be connected with the further processes, right? So I am using this as parallel connections, so I can make it a parallel connection here. Yeah, and after that, you can see every time you can see that the description pinouts of the particular VA, a particular tool VA. So here you can see the links resource. So once the connection was established, we have to connect that we have to make the connection for the next process as well. So that's why I connected the links resources to the remaining all inputs of the links resource. And now it is a Devo channel. So which exactly pin are you going to use for a particular purpose? So for my red, it is 8th pin, and it should be control that so that I can make a control option, and I'll make this as yeah, and this is done. Again, this is Devo channel is constant, which is a 10th pin, and again this is in control so that we can either switch on and off. And again, the third one is a constant, which I connected the blue LED to the 12th pin. And again, its function, which should be control. And we'll make all this in a loop so that when it will be in a loop mode, and once you are switch on or you switch off, it will take the actions properly. I'll keep it in a while loop for now. And while loop condition should be off whenever we make a button press. So I am using a stop button here. And after this, we have to terminate the connection as well. So here I'm showing only how can we turn on and turn off an external LED through Labview of the which the LED is connected to the Arduino board, right? So I have to terminate each one, the connection, so which can be closed out here. The close button, close. So all of them are closed, and you can see that our program is ready. You can see there are 3 LED buttons, right? And these are the default states of the button, but we can modify this according to our applications and requirements. So as they are mentioning that it is output value and output value 2 and output value 3. But she's with this, we are unable to find that which button is for which LED, right? So we'll give the particular name of our. So this is for red. This is for green. This is for blue. I'm expanding these buttons here. I will make in a line. So In this way, we can adjust the according to our view capabilities and etc. We can adjust the sizes and depends on our project. If there are multiple inputs and outputs etc. tools are here, we can make these sizes small. So we in this way we can adjust. So even we can adjust the color of this. So once I press this, it is a lighter. It's like kind of a blown button, right? Uh, while switch off, we can make it as a more a darker green. Here I'm going to properties of this button by turning clicking the right button and properties, and here while on it should be the this green. We can make it a more brighter and we can make it more darker. So in this way, we can modify the colors and we can modify the text, the sizes of the buttons inputs, and we can modify the text style as well using here. So the size, if I want a 24, we can see the 24 was on, and so suppose if I want a bold letter, then you can see the bold was appear here. In the same way, I can make a bold for everyone, and size should be green, sorry, 24. Again, size 24. Bold, yeah. Now, yeah, so now all these are ready and my program is ready basically. Now I'm saving this program. So, okay, I don't want to save this. Already one program was saved. Yeah, this package manager is ready now. You can see that there are several packages in this package manager. So which can be used for different instruments and different devices with different development boards. Like you can find Raspberry Pi or STM32 nuclear boards and Disneyland boards, etc. But our one is a Arduino board, you know, right? So we can type Arduino. Once you type Arduino in this menu, the search option, you can find these are the packages available for the Arduino board. So each one is for particular purposes, and here I'm using a Digilent Links one, Links VI package. So this VI can be useful for Arduino, Raspberry, BeagleBone, and Marimbo boards. So, but I am using only for Arduino board, right? So I can be install this. Yeah, yeah. Once you select this, and here there will be an install button highlighted. I have already installed. You can see that it's only uninstall button is highlighted now. So once you successfully install this, you can able to see the marker hub links here in the palette menu. Sorry, maker hub and links. You can able to see this. So now it means that I successfully able to install the marker hub package. And before running our code, we have to make we have to install the firmware of the links, our package. So the firmware means nothing but the predefined functions, so which can be easily understandable to the microcontroller. So with the help of this firmware, the microcontroller can able to understand our code as well. So here I have to use that, as I told you that this links package is for different boards, right? Right now I'm using Arduino only. Arduino manufacturer is Arduino, and the device type is our one is a Uno board, and our connection is a simple serial and USB. So there is no other connections in the on this boards. That way it is showing only one. And next one is now you have to press the next button, and then you have to mention, you have to say that which com board is with the Arduino board was connected, the particular Arduino board. If you have connected multiple Arduino boards, it will show here, and you have to select the particular one only. And I am pressing next button. So after selecting the COM port, you have to go to next, and here there are pre attached firmwares are available with this, and I am downloading them only. If you have developed any other your own codes or particular library functions, then you can in the Arduino ID that you can upload from here. But I'm using pre-built firmware, and now I'm uploading my pre-built text hex codes to the microcontroller. Now, so that the microcontroller can easily accept our code, easily can understand our code. Yeah, I'm finished, and yeah, my code is ready. Just I have to press this run button. Now you can see the once the connection establishes, it will show the Arduino board name. Yeah, you can see that. So it means that my connection is successfully established. If I press this button, you can see in the camera the red LED is blown. If I turn off, it was turned off. Yes, blue is turned on and blue is turned on, and I can turn on. So this is a very simple code to make you understand. I'm using this simple code to make you understand how can we interface an Arduino board with the Labview using the links. Okay, and now we can go little complex code. So yeah, here this VI I have developed already, which is you can see the file name here, right? So auto LED off and on. So LDR based auto LED off and on. So this is kind of a small automation system. So based on your daylight or based on your room light, if it is a if there is no light is on in your room, then this program will switch on the particular LED or particular light on automatically. It's like kind of when there is no power, then automatically it will turn on the LED. So this code, you can see that there are only 3-4 inputs and outputs, right? So this simple it is. You can see that. First of all, I'll show how this works. You can see in the camera that the blue LED will blow on when there is no when there is particular intensity in the my room gone off. So first of all, like I'll show you. I'll show you that I'm yeah I'm using an LDR here. So you already know the LDR how it works. So I'm just decreasing my light intensity onto the LDR, then automatically my blue LED is getting turned on, right? Suppose if I turn off my room light, I'll show you once. You can see that it was getting turned on and off, right? Um, I will show you how this code was built, and I'll explain. I will build together again. This again. Yes. So here again same thing. We have to make we have to establish the interface, and we have to define our COM ports here, or you can make it as a control, so that you can define it on the print face only. Print panel. Yeah. And after that, there is a loop again. And this loop, in this loop, now I'm using an unlock read button. So in the peripherals in unlock, you can see the unlock read here. Yeah. So I'm using this VA, and I'll show. Yes. So this unlock button, unlock read.va has the several inputs and outputs here. Again, same thing, links resource has to be connected once the links connection was established. And then unlock channel. So which channel, which pin are you going to use for your application, and error input and output. So again, there is if there is any RF reference voltage overrides are there, and you can define it here. And output is the whatever you read from the LDR voltage, the voltages from the LDR, that you can get the output here. And if there is any reference voltage are available, then that you can see here. So for our purpose, we need to see only the voltage read from the LDR, and I'm using a the DO pin is sorry, unlock channel is the first channel, so which is A1. I'll show you the Arduino board again. So here you can see that A0, A1, A2, A3, A4, A5. So my LDR was connected. Here my LDR is connected with the A1 pin. My LDR was connected to the A1 pin of the unlock channels. So so that's why I mentioned it as a one only. One, so the links package, in the links package for the unlock channels, you have to just mention either 1, 2, or 3, as they already mentioned that this is unlock. And but in the Arduino board, IDE, you have to mention that whether it is A0, A1, A2, because here it was not differentiate whether if you simply write 1 or 2, then it will take it as a digital pin. So for A1, you have to mention it as a A1. For digital pins, 1, 2, 3 up to 13 is fine. Okay. But for as they already differentiated with the VIs, and this particular VI can read on the unlock channel. So here that's why they mentioned they are giving us only one. So in their library functions, they will make it as A1 only again to make the understand to the microcontroller on the Uno board. Okay. So after making this connection, I am reading data from the LDR, and based on the LDR voltages, and I'm turning on the my digital my blue LED, which was connected to the 12th pin of the digital pin. Okay, so it's like I'm establishing the connection, and I'm reading the voltage from the LDR, and I'm just checking whether my LDR voltage is fallen below the set points or not, and then um, I'm turning it on, right? So if it is yeah, if my set point, sorry, my voltage is less than the set point, then automatically it will send, hello. Okay. Yeah. So it will, based on my inputs, it will LED. So, and after the loop is, so once you have stopped the program, then
ठीक है प्लास्टिक से
the,
वगैरह अंदर
the connection should be.
पाउच क्यों लाऊं
Okay, and for the observation of voltages, I am using a voltage chart here, and set points, I am using this set point. So which above which level the LED should be turn off and turn up. So that is the my set point here. Okay, let me see. So we'll build this code again together. I'll show you how can we build this. New VA, and again yeah, again we have to go to the marker hub. Yeah, I already kept a small VA here. It is open, and okay, we can close it later. Once you are open the communication, now it is an analog read. Once your analog read is done, then digital write. So before the digital write, there is a function, comparison function, right? So comparison, we have to go. So if it is my set point is less than or equal to the my set point, then LED should be turned on. So this is my process. So first make an interface, read the voltages from the LDR. So based on the light intensity falling on the LDR, it will generate the LDR voltage. So I'm here, my LDR is connected in a voltage divider method. That's why it can give directly voltage to my unlock pin. And now after reading the voltages from the LDR, if it is less than the particular my set point, then it will turn on my LED. So this is my flow easy. Now okay, this now I'll make the connections. So first of all, I have to read, wait, I have to make a channel which port was connected. Here it is. And then for verification, I'll make an indicator here. Okay, once the connection was established, then links resources should be connected. And for the error, if there is an error generated here, if you don't make a connection in between these two, then error will be shown here, and the program will be terminated after this execution only. But in some applications, we may ignore some errors here, but we have to completely terminate the connection. In such cases, we have to make this connection so that errors will be passed and up to the close button, the last function where the last connection was made for the error passing. And once you read the voltages, sorry, you have to make which channel it is. So I'll make an analog control button. I'll make this one as well, control, change to control. So create control. As I come. Yes, I can simply use. Okay. Once it is read from the LDR, and now voltage will be output voltage will be compared here, and I will make an control here so that this is my set point. Okay. Yes. Once the set point was below the particular, once the voltage from the LDR is below the set point or equal to set point, then automatically it will give this function will give if it is whether if it is true or false. If it is less than or equal, then if it is x is less than or less than or equal to the y, then it will give true as output as a true or one. So that true or one will be applied to our digital pin here. Yeah, and create controls. Sorry, constant is fine. DO channel, create control. Now my blue LED was connected to the 12th pin of the digital pin. Okay. Before that, we have to make the connections here, links resource connection. Okay. Now I'll keep all these in a loop so that it will be continuously turn on or off. Our LDR will be continuously monitored and output will be continuously varied. So I'll put a stop button here for the loop, and then after all these are executed, now we have to close the buttons. So now we have to close the function. Make it pass. Okay. Yes. So yes. Yeah, I'll use a graph indicator, graph waveform chart, so that I can observe my voltage continuously, whether they are falling or not. Okay. Yeah. So my code is ready here. If you want to write this same code in the Arduino IDE, it is a very big code, as you have to mention each function you have to define there. But most of the functions are already defined by the links. Just you have to make the connections between them according to your applications. So that's why the Labview is simple for hardware interfacing. I'm making this. I can make an indicator as well here. Create indicator so that I can observe the output voltage. Voltage read by LDR. Yeah, now program is ready. I have given the name and my lock channel is 1, and I can make it these two separate. And whenever I want to stop the program, I can make a stop. Okay, for verification of the connection, I can see the, yeah. Now I am going to run this code. As already firmware was installed on the microcontroller, I don't need to again upload my firmware here from here. Okay. You can see my LDR is reading voltages, and in the camera also you can see that if I put my hand here, I'm blocking intensity on the LDR. So this is my LDR. Okay, I'm blocking the intensity. So you can see the variation. Yes, I'm completely closing this. Now it is fallen to very low values. And now it is above 4.5. So you can see that when I'm closing this approximately up to here, so the voltage is around 4.55, right? 4.5 to 4.55. So I can keep the set point in between. And I can keep the set point as 4.55. So that once if I reduce the intensity less than the 4.55, okay, we can use 4.6. You can see the blue LED is getting on, right? So you can see I'm blocking the LDR. I'm blocking the light to fall on the LDR. So then automatically once the LDR's intensity, the voltage read by the LDR is less than the set point, then automatically it's getting turned off. That you can see here easily. Okay. Now I'll turn off my room light. You can see that now as the set point was varied, you can see in the graph that now the voltage is around. Okay. It's reading properly. So now my voltage is very low. Yeah. Why should be my voltage here? Yeah. Yes. Yeah, you can see that once my room LED is gone bad. Sorry, I have some loose connection here in my LDR. Yeah, you can see the voltage falling very good now, but yeah. Mm. Okay, I'll use my hand only. I don't know what is the connection between my room light and this. Yeah, I'm locking the intensity, and whenever my intensity is falling less than this set point, you can see the LED is getting on. So it's like a kind of automation, right? So whenever I don't have any light in the room, in my room, it will get turned on. So instead of the small LEDs, you can make a some tube lights or any other thing with the same program. You can control those things, but you have to make some driving circuits for that. So yeah, this is how the simple way for automation of the LEDs. Uh, some small automation program, uh, and you can see how easily you can build the programs in the LabVIEW. Even complex programs are very easy. You may feel that these are also is complex thing, but it is a very a simple way. But for the same purpose, if you want to build a code in the Arduino board, you have to write so many things for even for observation of charts and voltages, etc. You have to prepare your own GIs, etc. Right? So that it takes much time. But here all tools are available in the Arduino, so that's why we can use whatever the tool you want, whatever the inputs are, input knobs, input buttons, or output indicators, or waveform graphs, etc. For the monitoring of the voltage, input voltages or output voltages, you can use any of these graphs. Even you can make images as well. You can um, build the vision based applications as well. So that I think I have in the afternoon session for the vision. And yeah, so these are the simple methods for the LDRs. And I have these two only right now. You can ask some questions now if you are any. So, hello.
Hello, sir. There is a
Yes,
question in the chat box.
yes, yes.
Can you explain the connection between LabVIEW and Arduino?
Yeah, sure. So first of all, I told you that the Arduino board is a like it was built based on a 80 mega. The current board what I am using, the Arduino Uno board is built on using the 80 mega 328p microcontroller. And this microcontroller will have proper set of functions that you have to mention to make it understand, right? So for that things in LabVIEW or any other program, you have to define those functions, etc. by your hand. But in LabVIEW, we can get some packages, or in any other language as well, we can get some packages, right? Like even in the Python as well, we can get some packages, C++, you can get the packages easily. That those using those predefined packages, and they're predefined by calling their predefined functions, so we can make the communication easily. Here I'm using using the Python manager, sorry, package manager. Yeah. So while you are installing LabVIEW, the LabVIEW installing page will ask you to install this one also. So you for the hardware interfacing and to install any LabVIEW, sorry, related packages, you have to install this app. along with the lab installation as well. So once you are open this that VA package manager, it will take some time because there are so many packages are has to be loaded. So while you are opening, it will take time. So yeah, once the packages are available, you can install a package called links. Okay. For this application, this yeah. For this application, I'm using a package. I have installed this package called Maker Hubs links package. Yeah, you can see here in my menu, palette menu. Yeah, you can see the links package here. So the links package is usually for the Arduino boards. They build this package for various boards. One of them is Arduino. So you can call whatever your board is, which can be supported by this package. So first of all, to make the connection, you have to dump this predefined functions or firmware. It's called firmware that can be installed from here. Once you are install the links package onto the Labview, now you have to dump their firmware onto your board. So for that, you have to go to tools and Maker Hub and links and links firmware wizard. Okay. So this is now as I told you, the links package supports various boards. So among them, we are using Arduino now, and right now I'm using Arduino Uno board. So I have to select this board as well. And my connection on this board is only serial or USB connection. There are serial pins here, 2 pins. You can make the connection from here as well, or a serial connection here, USB connection. So that is my uploading method. And now we have to go to the next menu, and in the next page you have to mention which port was connected with the Arduino board. So as I told you, in the Windows 11 or 10, when you right click on the Windows button, you can see the device manager here. And yeah, just a second. This is my device manager. In the device manager, you can see under ports, COM ports and LPTs, you can see the particular port name number. So from here, you can go to the, you can select the particular COM port and next put the next button, and I'm using the pre-built firmware only, so I don't need to change anything here. Once you press next button, it will start uploading the pre-built hex codes, which are which are nothing but the pre-built functions. And the functions means the each VI here, open VI, unlock read or digital read VIs, everything, all of them are functions only, predefined function. So we are just making the connections here to calling those functions, and we are just giving the required variable inputs or outputs, taking the outputs from those functions. After executing this function, we'll get the output and we can observe those from here. So this is the basic method, only method for this links, to use the links package for interfacing Arduino. Okay, yeah, in the VI package manager, as I told you earlier, once you install this VI package manager, instead of going through all these things, you can just simply type either links. If you know the particular package name, you can type links, or you can type Arduino, the board you are using, either board or sensors or anything, whatever the package available here, that you can set here, and the available packages are showing here. So right now I told you that I'm using the links package, and which is here. Just once you are highlighting this, you have to install this function package. So, and this package was installed. You can get the in the pellet menu. You can easily get the uh, Maker Hub's name here. The tools are available now here. Yes. Yeah, I hope you understood. Or do you want me to repeat?
I'm sure, sir, the doubt that the student has asked, rather Kaustubh sir has asked, I'm sure he must have got a good explanation on this. Yeah, thank you so much, sir. Thank you so much. Any more doubts, my dear participants?
Okay, there is one more section I can explain as we have 1 hour more, right?
So yes, sir, we do have 1 hour more. We will be starting our session at 2 around.
Yes.
And
You can ask me questions now, or I gone a little fast actually. You can ask any question, no issue. Just I shown you the simple methods for interfacing. So
yes,
based on your requirement, if you have some analog sensors or digital sensor, you can use this small board for your requirement for small projects. Like you can, as I told you, the LED on and off VI. You can use it for a small project for traffic lights on and off,
right,
automatic
right.
off.
Yes,
Yeah, you can make a program for that. Yes,
yes,
and
yes, sir. Thank you, sir. Thank you so much.
yes. So I showed the for hardware interfacing in the LabVIEW NIMAX.
Mhm.
There is a tool called NIMAX, which is crucial for hardware interfacing. Suppose if you interface some instruments or anything, there here you can test those instruments before making the connection. So if you can ask any doubts as well for the previous explanations, and we can go through this one as well. Yes. So here the NI Max means NI National Instruments Measurement and Automation Explorer. This is the this software called, and this is also while installing the LabVIEW, you have to install this package basically establishes will make the good connections between the instruments and PC and LabVIEW basically. So here in this menu, you can see the different various devices connected here, and you can make the connections. So you can see even see that my webcams are connected, and my COM4 is nothing but my Arduino board. So here there is a test panel as well. In the with a test panel, you can test the device, the whether it is working or not, or whether the if there is any connection errors between board and between the board and the PC, then you can test it here. So for the instruments, this is much more useful instead of these small development boards. Um, like if I write some query here, it will give the response. So particular commands you have to know which command you have to call for that. So this is a testing bench basically. And yeah, this NMAX is much more useful for mainly for the instruments basically. In the for the lab instruments, LabVIEW is a very good platform to develop the programs or develop some basic some good complex programs, etc. And for your projects as well, students projects as well. Yes. So I don't have any instrument, otherwise I can take a good session on this. Uh, okay. Okay, man. So I am done with now.
Yes.
But if you want repeat anything, I can repeat as we have left the time.
Yes,
Other-
sir. So we have time from I guess from 2 o'clock.
Yes.
So probably then we can discuss further.
Yeah. So yeah, for the 2 o'clock session, yeah, there is a good project. I can explain how can we integrate our a camera or for vision purposes.
That would be really nice. Yes.
I can explain how can you make an attendance system as well using
Wow.
just
That
QR
a
code
class
based,
monitoring system, class attendance system, right?
a QR code based system, so that I can explain in the afternoon as well. Yes.
That will be really nice, sir. Very nice. So should we take a break now, sir?
Yeah, sure.
Okay.
Yeah. Thank you.
I'd like to really thank Shriman sir for explaining us so many intricacies of Arduino and Labview interface, and letting us know that we can make so many projects with the help of these software and hardware together. And thank you so much, Shriman sir. I request all of you to kindly gather at 1:50 sharp so that we can start the session on time.
Okay.
Thank you, sir. Thank you, everyone.
Thank you.